Hello friends and welcome to the discussion of JEE Mains paper 2020 of September edition. So let's start. If you see the first one, it's a problem based on integration, indefinite integration. Seems to be a very easy one because e to the power x is there, so somewhat like e to the power x, fx plus f dash x may be there. We can just have an idea like that, but yes, not so easy. We can just rate it as the medium one, right? So let's have a look at it. See, you have been given e raised to the power 2x, you have been given e raised to the power x, e raised to the power minus x, right? And also you have been given e raised to the power x and e raised to the power minus x. Now to bring it to the form of an integral which will can be solved using method of by parts, let's see if we can do it in that way or not. So let me take, say, e to the power x is equal to, say, t we can take, right? Or we can just find dt upon dx, which is nothing but we have e to the power x, or we can write it as t itself, okay? Or we can write it as dx, which is equal to dt divided by t we have, right? Now, this integral can be written as t square. This is 2t, right? And this is coming out to be minus 1 upon t. Then we have minus 1. And then we have e raised to the power t plus 1 upon t into, this is dt upon t we have, right? Now we can write this integral as t square minus 1, right, times t plus 1 divided by t square. You can just have a look at it. This is plus 1, right? And this can be written as e raised to the power t plus 1 upon t, which is dt we can write, right? This is a very simple calculation. You can do this calculation part, right? Now, what we can do, we can just have a look at this. See, t plus 1 is there, so yes, we can just write t plus 1, isn't it? And we can just multiply. So this is coming out to be 1 minus 1 by t square. And this is e raised to the power t plus 1 upon t we have. Got it? And this is dt, right? And this is what we have, e raised to the power t plus 1 upon t, which is dt we are having, isn't it? So that means if I talk about this part, so here we can use the method of by parts. So this is like, if I take this as a first function and this is a second function together, right? So that means we have t plus 1. And if we integrate this part to t plus 1 by t can be taken as x, we've integrate this, so we just get t plus 1 upon t we get, right? And here again, because we have taken that as an integrate, so this is minus of, we have taken dt of t plus 1, right? So that is 1. Again, the integration of this part, what we get t plus 1 by t. And this is dt we have, and this is plus e raised to the power t plus 1 by t, and this is dt we are talking about, right? Now this is cancelled, my dear students, okay? As you know, t plus 1, so t what we have taken as e to the power x. So this is e raised to the power x plus 1 we have, right? And this is coming out to be e raised to the power t and e raised to the power 1 by t. So we have e to the power x plus 1, right? And e to the power t means we are talking about e raised to the power x, and this is again we can write it as e raised to the power 1 upon e raised to the power x, right? So what we have been asked to find, so you just have a look at this part. So it has been given that this integral is gx into e raised to the power x plus e raised to the power minus x. That means we are talking about this. So this is nothing but gx we have. So you can just see the integral here. So gx is equal to how much? We have e raised to the power x plus 1, right? And what we have to find, let's have a look at this part. What we have to find? We have to find g of 0. G of 0 means we are talking about this. G of 0 is equal to e raised to the power 0 plus 1, which is 1 plus 1, which is coming out to be 2 here, right? So what is the option we have? We have the third option as the correct answer, right? Now let me go to the next question, students. Question number 2. Where lambda belongs to R and the system of linear equation 2x1 minus 4x2 plus lambda x3 is equal to 1, x1 minus 6x2 plus x3 is equal to 2. We have lambda x1 minus 10x2 plus 4x3 is equal to, we have lambda x1 minus 10x2 plus 4x3 is equal to 3 we have, right? And this is inconsistent. it has been given inconsistent, and we have been given 4 options. So just have a look at the options. Exactly 2 values of lambda, exactly 1 positive value of lambda, and every value of lambda, and exactly 1 negative value of lambda, right? Going to a very interesting sum. So whenever you say inconsistent, the concept of Cramer's rule can be used here, okay? So what is Cramer's rule? I hope you know what is Cramer's rule. So this is nothing but we have d is equal to 0. For inconsistent, the coefficient matrix, the determinant of that matrix is going to be 0, right? For inconsistency, condition we have. Now d is equal to 0. So also at least one of the determinant, either that one is d1 or d2, d3 is non-zero. At least one. This is also one of the condition for the system of equation to be inconsistent, right? So that means if I talk about d is equal to 0, so d is equal to 0 means we are talking about this determinant, say. So we can just have a look at this part. We are talking about the determinant now, right? So just have a look at this. See, this is the determinant, twice of minus 4 lambda, right? This is d we have, right? And this is 1, this is minus 6, and this is 1 we have. Then we have lambda, this is minus 10, and this is coming out to be 4, right? Which is equal to 0 we have, students, right? That is the condition for inconsistency. So that means if I solve it, if I simplify this, we get lambda minus 3, right? And then we have 3 lambda plus 2 is equal to 0, right? That means we have lambda is equal to 3 and lambda is equal to minus 2 upon 3. So these are the 2 values we are getting. Again, there is one condition that at least one of d1, d2 or d3 is non-zero for any value of lambda, like lambda is equal to 3 or maybe lambda is equal to minus 2 by 3, right? So let's have a look at this part. Let's find d1. So if I talk about d1, what we have? We have been given d1 as, we just substitute the coefficient of x1 here in the first column by 1, 2 and 3, right? That is the method what we use in Cramer's rule. So that means we have 1, we have 2, we have 3 here, right? And we have been given minus 4, and this is, we have minus 6, this is minus 10 we have, right? And we have been given lambda 1, and then we have 4 here. Got it? So this is coming out to be how much? Let's have a look at this part. This is nothing but we have twice of lambda, that is 3 minus lambda we have, right? Just see. So you can see here, we have been given 2, 3 minus lambda. I mean, this is what simplification has been done. You can just take the determinant and we get the values. Now we see lambda is equal to 3, lambda is equal to minus 2 by 3. Now if I check with 3, we get 3 minus 3, which is coming out to be 0, right? We have to take it, say, if we can just prove it d1 to be non-zero, right? That means this negative value is working here. Minus 2 by 3 will make it not equal to 0, right? That means exactly one negative value of lambda will give this system to be an inconsistent one, right? So hopefully these problems are clear to you. Now friends, let's talk about a very interesting problem, that is question number 3 we have. If the function fx is k1x minus pi whole square minus 1, where x is less than equal to pi we have, right? k2 cos x, and this is x is greater than pi we have, right? And this is twice differentiable, right? So that means if you just see the things, if we have been given fx, let us find f dash x also, right? So what is f dash x? F dash x is nothing but we have twice of k1, and this is x minus pi, right? And this is coming out to be minus k2, and this is sine x, okay? And this is nothing but we have x less than equal to pi, and this is x which is greater than pi we have, right? Similarly, if I talk about f double dash x, you can just have a look at this part. See what do we have? F double dash x. So f double dash x means we are talking about what? We are talking about differentiation of this, that is coming out to be twice of k1, right? Which is x less than equal to pi, isn't it? And we have minus k2, so this is going to be minus k2 cos x, where x is greater than pi we have, right? So students, what we can do here, yes, because this is a differentiable function, so we can say differentiability implies continuity. That means let us take 2 options here. just because this function is also going to be the continuous function we have, so, and this is also going to be the continuous function. So we can use this, right? So that means we are talking about something like x is equal to pi, if I check it out. So left hand limit is equal to this. That means we have minus 1 is equal to how much? We can take this as k2, and this is cos pi we have, right? So cos pi means we are talking about minus 1, so k2 is equal to how much? We have 1. That is left hand limit is equal to right hand limit we have, right? Similarly, if I talk about f double dash x, so what we have been given twice of k1 left hand limit is equal to right hand limit, that is nothing but minus k2 into cos pi, that is coming out to be minus 1, right? So that means we have twice of k1 is equal to k2 we have, right? So k2 is equal to how much? 1, right? So this is coming out to be 2k1 is equal to, we have 1. So k1 is equal to how much? We have 1 upon 2. So what we have used the concept of continuity here. So this is the first case we have taken, left hand limit is equal to right hand limit, and value of the function obviously. So I have taken two limits only, left hand limit and right hand limit. Here also I have taken the left hand limit and the right hand limit, and we get the values as k2 is equal to 1 and k1 is equal to half. So k1 is half, right? And what about k2? K2 is coming out to be 1. So fourth option is the correct one we have, right?